what you are delivering, they are listening or not, also we doesn't know. Because I am seeing my children, they are almost, they are using in the classroom also online videos. Even school also, Byju's app, there is a lot of things. Okay. But first important thing, everyone in the entire world, now they are talking about the quantum. Why we require? Because there is a mathematics, physics, lot of other disciplines also there. We have to look back in the 60s. Because we have theoretical concepts from ancient age. There is a lot of mathematics, science, what we are talking about, all the areas concept of science. Slowly when 1940s, they are trying to include so many complex problems like Ramanujan equations, numbers. If common man can understand, it takes a lot of time. Years together also they studied. Slowly they introduced Turing machines in the computer science, basic theoretical concepts. We need another methodology for simplification of especially expressions. Slowly linear algebra concept is given. So for example, if you want to calculate a simple sum of two numbers program, if somebody says they write one line or two lines code, but if I want to write, I want 1000 pages. Because once if you question, what is the range, what you have declared, what data structure you have declared, what automatically your program have a lot of limitations, but not in the pattern. If you want to add 10 power 350 into 10 power 350 number, then no computer can perform. Because limitation, because whenever you have declared a variable, the maximum range is 10 power 305. That other which is allocated the bits. That is the maximum text. Okay, that is the one way. First, basically, I want to tell these algebraic expressions. If you give it to the system, then it can perform faster than the human being. Slowly, they introduced binary system. Because why the binary system is there? They will simply tell, if you want to calculate sum of two numbers, what we'll do in programming, especially in the computer side, whenever you use the C programming language and any other thing, first we convert it to assembly language. That assembly language simply add A, add A, add B, add small instructions. No, assembly language. Mnemonics. These mnemonics we are converting into actual machine code in the form of zeros and ones. And once the binary system, because the computer supports only zeros and ones, whenever a new numerical number system comes, the binary should perform all operations. Otherwise, we will not accept as a number. But as per the Turing machines, first theoretical computer, it can do only addition, one direction, only addition. So, using only addition, we should perform all other operations. So, we can able to do with the binary numbers. So, automatically, number system is came. Next important thing, in the computer, how we have to give? How do we have to give it to the machine? These zeros and ones. Initially, PA junctions, later transistors, later ICs, later microprocessor, error we know. But basically, these all operations are performed using a gates. Sum of two numbers, OR gate, sum of and there is a lot of gates are there. Once the gates concept also diagrammatic representation only, because the entire world everyone can understand. Next, implementation. How we have to implement the computer. So automatically 0 and 1. 0 to 0.8 volts we are treating as 0. 2.5 volts to 5 volts we are treating as a 1, and 2 voltage levels we have considered as 0 and 1, and using transistor because the collector, base, emitter and ground. When we give a 5 volts to the collector and if we are applying 0 volts to base, nothing in the base, then collector voltage as it is will get 5 volts, that they are treated as 1. When we apply base voltage, the 5 volts through transistor starts functioning, it comes through emitter, it becomes 0, and the collector will get 0. That is the 0 state, 2 states. The transformation of state requires some time. That may be microseconds and milliseconds or microseconds, but time is required to change the transition state. So these gates, they are used to construct gates. These transistors we are using to construct the gates, and these transistors diagrammatic representation is gate, but physical construction is using transistors. So 0 and 1 we are giving to the computer, and we are getting required or expected output from the output device. That is the first presentation of 0 circuits. Slowly these gates becoming a sequential circuit or combination circuits. Later the need came to store the information. So slowly latches and flip-flops concept is given. Each flip-flop capable of storing 1 bit of information. So automatically a group of flip-flops, we are talking about registers and buffers. Slowly the number of bits we are increasing, and a combination of gates and the flip-flops we are using to solve the expressions. That is the basic mathematics. Because now if we use the computer, see the computer, what purpose we are using? Initially for mathematics, later for word, storage of the data. Now artificial intelligence also we are using. Everything should convert into zeros and ones. Slowly, once we observe the first personal computer in 1980 with 128 KB RAM, not even RAM, and no hard disk, only floppy drive, OS also through floppy disk. Initially, the cost is first PC in 1980 2 lakhs. At that time, properly salary is 100 or 200 rupees. So just imagine 200 times of the one common salary your computer cost. And slowly, lot of research is done on that. The recurrent process speed, that is the number of transistors we are increasing. IC scheme, IT system, microprocessor, era scheme. So total world last 120 years, 2002, 100, 200, 1900 to 2020. Only one new invention is microprocessor. It changed the entire world. Next we require another invention, because again the scenario is same. Your communication is increasing, your computing increasing, and we have came to the solution that we cannot minimize the microprocessor further to double the computing speed. Why we require this much of processing speed? Because the use cases are more. Because all our researchers, if you want to put any proposal or if you want to do the research, you require a use case. If I was given a computer, quantum computer to you, what purpose you use? You use for sum of two numbers? No. As to first of all, we doesn't know for what purpose we require quantum computer. So we need a use case. For example, if share market today, share market is there. Share market probably 40-50 years. Every day, if you observe the transactions, millions of data is there. If you want to predict something, you want to do analysis, your classical computers requires years time. So your classical computers doesn't support, even though if you go for the CPU, GPU, all the processors. So that's why we need another computing device which can require a total change of your conviction approach. your transitions will not work because transitions require some time to change the state, and the constraints only two levels, 0 and 1. We have not done any further research on that. All the microprocessors, everything on the binary system. But if you are increasing the processor data bus, because initially 1980s, 4-bit computer, 8-bit computer, now we have 64-bit computers. 64 bits parallelly we are sending to increase the computational speed. So that is the data bus length. This 64, suddenly I want to make it 1 lakh, it is not possible. Your microprocessor doesn't support. So automatically we need further new computation with possibility of only 2 levels. So the scientists thinking that the basic scenario should change first. There is 2 aspects when you observe your mobiles, when 3G to 4G, 4G to 5G. If somebody having 3GC, you cannot insert except BSNL. Still they are using old BSNL towers. If you want to buy a 2G mobile, you never will get a mobile. Even if you buy the mobile, there is no SIM supports. Why? Because the entire world, 800 crores people, you want to replace the mobiles. That's why they are changing the technology. Now the entire world, the computer era should change. They basically want to make a market. First thing. Because strictly we are speaking, quantum computers now requires only the research labs. Only the companies like SBA or share market or only class A companies that for our purpose is not required actually quantum computer. Because now cost of the quantum computer is approximately 5 crores. As per my knowledge, it is not expensive. Why? Because if my salary is 2 lakhs, you observe it is not 200 times like 1980. Suddenly it becomes less. Very few years, quantum computer also will get from 3 lakhs or 5 lakhs. At that time, everyone's salary is same. Because every year we are seeing salaries. So 100 rupees salary, 2 lakhs. 1 lakh salary, 20 crores is not a big deal. Because it's start together. First, what we have to learn, if you want to change the total system, they are thinking that how to represent the zeros and ones, because there is a lot of fluctuations in the voltage and current. If 0.82 to 2.5 volts comes, no one can decide the zero state or ones, which is the intermediate state. That first we have to know. So that's why they are taken atomic structure, nucleus, electrons and protons. So whenever you are hitting with high energy photon, in India there are so many accelerators are there. Inter-university accelerator centers at New Delhi and Calcutta, that is like a Institute of Physics, Bhubaneswar, Saha Institute of Nuclear Physics, and Inter-University Accelerator Center at New Delhi, with just backside of the AKNU. There is the accelerator centers are there. Whenever you put a foil, thousands of atoms, lakhs of atoms, if we hit with high energy photon, we can jump the electron from one level to another level, K level to L level, L level to L level. Because the photons and neutrons we cannot change, because it is the nucleus. Electrons are revolving. Electrons we want to make it into next jump. So that is the superposition state. When electron is going to jump from K to L, we can treat as 1. When you are coming back, we can treat as 0. Like this 0 and 1, 2 states that are proposed by initial stage. So this quantum bit concept is started from there, because we know the electron properties. It is very faster and it requires a picosecond is sufficient to change the state. Because whenever electron revolution around the nucleus, it is more than speed what we are expecting. So if your transition states comes in the type of fraction of microsecond or picosecond, So that will be useful for our computing speed. That's qubits concept is here. And another thing, this state, like not like your classical bit, number of bits we can produce. Not only 0, 0, 1 or 1, 0, 0 or the 2 bit, 3 bit or 5 bit, 10 bit. Qubits computers, 20 bit qubit computer also. Once, if you want to calculate sum of two numbers with giving two variables x and y, you need to use your brain to calculate the sum. If you use only two variables, certainly one variable data will vanish. X equals x plus y. If I have given three variables, z equals x plus y. So no need to change. If you give four variables, like this, if you increase the variables, expressions will become small. And computing speed increases. So that is what we have got the concept from the starting zeros and ones. Initially they have taken the properties of the atom and they started representing a qubits. So once a qubit introduced, then what is the next? This qubit should perform all operations, otherwise we will not accept. Should perform addition, subtraction, all the representation, all arithmetic operations, remaining operations should perform, then we will accept. How they have to perform, because this is the hardware you have to design. So slowly, quantum gates concept is what yesterday the second lecture told, quantum gates. Because for operations, because there is a one disadvantage with the quantum qubits, we cannot store anything. Classical bits, we have flip-flops, we can store. We can keep. But here, the concept is different. Only superposition and transformation phase, we have to do the computation. Immediately you can get result and you can give it to some other place. We cannot store in the hardware level, we cannot store everything. It is a classical bits we can store. Zeros and ones, flip-flops, a certain time you can maintain the state. But qubits you cannot maintain the state. Still the challenge, you can go for the research, can we store the qubit state? Because the lakhs of atoms, it is not like a single transistor, 1 bit. Two transistors, 2 bits. No. Because even you take a single qubit, lakhs of crores of atoms will be involved. We doesn't know how it behaves. So only the probability of the bit we can take, but we cannot get all the things in one state. Because what in the yesterday's classes you listened, the state maintenance also is not a thing. Because the magnetic field we cannot get. That is still at present, all outputs getting from the quantum computers are very noisy. It is not still it is under research. Noisy output only they are getting now. So for that particular purpose, what we have to do? We have to go for the simulators. Because we don't want exact quantum computer. Quantum simulators which can perform. Because basically mathematics people knows. Initially when arithmetic expressions, if you want to solve on the computer, they can put in the simulator and it will work. Lot of simulators are there. For example, entire world and network environment is there. Lakhs of routers are organized. If you want to do study, we will study only simulator. On the simulator first, we will create the nodes, we will create the properties, we will give the time, everything we will give the parameters, and we are working and we are getting the result. The same thing, now we cannot work directly on the quantum computer and we can go for the simulator. So, if you want to do the quantum research, quantum gates, what yesterday gates they are shown on the quantum.ib.com. Quantum platform, it is a free documentation also there. QS kit, there is a lot of tutorials are there, documentation is there. You can use that one, but it is on the not exact on the computer, quantum computer. They are giving simulation. And this quantum cloud platform, it is a direct cloud platform, and they are giving hardly 10 seconds per day. They are using for free of cost. Later, this is a paid version. If you want to use a computer for 10 seconds, how efficiently you have to design your code. That's the important thing. Once we are going to the code, we need to write again algorithms concept, quantum algorithms concept is here. So because if you compare each and everything from classical bit to quantum bits. So everywhere starting from the bit representation and gates, next when you have any arithmetic expression that should convert into gates, and in that gates to solution you have to bring. That is the first part. In the basic level. Once your tasking, computing use cases are replaced. For example, if you want to do analysis next 1 hour, what is the prediction in the stock market? Once if you talk about the stock market, how will you predict next 1 hour? Because there are a lot of parameters are there, stock market. If somebody studies, if a US president announces something, immediately stock market will collapse. We don't know the dependency, but we know that. That's the one factor. If some other country, a war started, then Indian stock market may increase or may collapse. If our country is depending on the other country, then stock market collapse. So these are the parameters if you want to consider the entire world, 190 countries. Data we require every day. One of the news channel you have to take the data and you have to do analysis with the fraction of a second. If your prediction is after 1 day, no use. Before the market will already close. So like this, now DNA, your human health, it is one of the major challenges. So I will just 1 minute. Because your theme may be not included in any one of the lecture, so I will give directly your opportunities in the quantum computing and what are the threats we have to face. Because theoretical concepts anyway speakers will tell. Threats of speaking. Better. No better. So all of you understood the basic concept because the zeros and ones. First we are going the total scenario we are going to change. If it is comes, what is the next? We need operating system, we need apps, we need softwares, everything should change. Like 64-bit operating system, 64-bit apps, it will not install on the old machines. So we need a new software, total world, total IT industry. We require millions of people require to develop the operating system, to develop apps, to develop softwares. Okay, next. So this quantum computing basically quantum computing exponentially speed up for the certain algorithms. These are the various applications and opportunities. In the pharmaceutical industry, accelerated drug discovery through quantum simulation of molecules. Because I see some of the pharmaceutical companies, they have thousands of IT employees. Because previously, pharma company for only drug discovery and now the IT people are working. Because especially the example of coronavirus, our Indian brains, they discovered the drug very fast when compared to others. Because we have efficient analysis scientists are there. So that is the first thing. Second is the finance sector, portfolio optimization, risk analysis and fraud detection. I think knows the share market, those people knows the portfolio. For example, if you want to start buying the share market, which shares you have to buy?
We need to know about the company which has
Yeah, company fundamental. Yeah, company fundamentals, and especially if the subject is not having blue chip shares. And the company's fundamentals are depending on what? Your director, employees, and history, and what percentage their sales, everything. Lot of people are there. Lot of that thing. That portfolio we can optimize. Now there is a lot of tools are there. It will tell strength of your portfolio also. Next is the risk analysis. This is playing a major role in the banking sector. So there are so many people every day they work on the risk analysis, because whenever you are introduced to one new model, one new system, there is a lot of hackers, cyber crime. How to pick up? Because last week my friend is working in the city of one of the banking. They have observed crores of fraud. Simply they will hack the money. They will transfer to one account, and that account too they will transfer to another account. Immediately they will close both accounts. History will not comes, because when you have a small branches, once the account closes, then it is very difficult to find out. The sequence of chain, how to trace that one risk, because there are some banks. They will not observe KYC properly. Small branches. If KYC is not properly filed, how we can trace out the customer? That is that for verification agency. That is the risk, and this is the fraud detection. In the logistics, route optimization in supply chain and traffic systems. So, for example, I think everyone knows the chain market. For example, if you want to take a petrol bunks, we have a number of petrol bunks. Basically, HP, Hindustan, Reliance, bunks are there. For example, if HP refinery is in Vizag and Indian Oil refinery in Rajahmundry, if someone wants HP petrol bunk, can we bring petrol from the HP? Vizag? Why unnecessary traffic? So we needed optimization. Otherwise, this Indian Oil will supply, and the HP supply to the Indian Oil box, the transport will get reduced. There is a lot of cement industry also they are following. They put a brand, their internal communication, you cannot find that one. So like this, there is a one thing, and another one, especially we are listening canals. Suez Canal, foreign countries, international traffic is most important. Traffic optimization. For example, India to US ship and there is a proper route. The canals optimization is playing a major role, because you doesn't know, but major transport is ship transport in the entire world. Because we are not in that market, the optimization routing is the major challenge, and finding the ship when it is traveling in different places. So supply chain in a similar way. AKNU algorithms, everyone knows. Machine learning algorithms, why are quantum enhanced model? A simple thing I want to tell. In the first year we will study the data structures. What data structure? A well-organized collection of data and a set of rules to access the data. If we ask to calculate sum of two numbers, immediately we will declare in X, Y. X and Y is the data structures. Because you are deciding this data structure, how to hold your input. So when slowly increases, your basic data structures are not sufficient to analyze. So what is it? Slowly, there's a dark concept is there. Design and analysis of algorithms concept is there, and they are optimizing all the data structures, how efficiently we can store and we can retrieve the data. Still data is used, we are going for the data mining. Still data mining is algorithms also not sufficient. We are going to the data warehousing or storing and machine learning concepts are there. Still we need some more analysis, deep learning. So now we require quantum machine learning. So because every day use case is increasing, input is increasing, so automatically opportunities increases. And there is a new quantum machine learning algorithms already came. They are working on the simulators. So once we are coming to the quantum communication, this is the one of the important area. Quantum key distribution in ultra secure communication. Now most of the software companies now using quantum cryptography for generating key, because we cannot clone qubit. We can clone any other classical bits, but we cannot clone qubit because we cannot trap anywhere. Because very fast, we cannot clone. That's why even I know that like a JP Morgan, Bank of America, they are using quantum cryptography for generating a security codes. So that is the even just a chapter. What's that? 2 minutes. So most of the companies, they are generating quantum qubits secure, and that diagram also, because the last few days back we went to the Vijayawada one workshop. At that place they have displayed the quantum computer and quantum key, that quantum key distribution mission and the setup also that's displayed. Already some companies they are following. And this is the satellite based with quantum links, and no cloning theorem ensures the endless detection. That's the important thing. Opportunities in the quantum key distribution, satellite communication, and the cyber security. Madam, can I stop? My money time not because I am working from last 1 month. I am not very old researcher. From last 1 month, I am working on the quantum computing, because basically I am a pure specialization. Basically I am a physicist. I studied MSc physics also, especially in nuclear physics. The quantum computing is helping now. So we need to understand the atom, and because you see the universal structure and atom both are same. Both we cannot see, because there is a lot of mystery in the world. Still we are unable to break. Maybe quantum computing will break. We can introduce the systems faster than the light, because we require some more systems. We want to make faster systems. We can transfer the data without any delay. Certainly, when time comes, human also will convert into qubits and will transfer it. We will again reassemble wherever we require. Because this is there in the ancient scripts. We cannot make it as a joke, because in 1956, when Mayabajar movies came, he is having a laptop with net meeting. Now we are at it. At that time there is no computer also. How the director, is the greatness of the director or writer? Because that is there in the old ancient scripts. Everything. Now human cloning is also there. What we have talked about, I am not talking about God. He is a computer scientist. He knows all the computer technologies, and we doesn't know. That's why we are calling as God. Everything, it is a technical switch. First thing, why he is not explained to others? Because we are not capable of understanding. If somebody talks about the quantum computing, how it works, we cannot understand. Because yesterday, when the first session, when it comes to the polynomial section, I am not understanding, because I am not a mathematician. Then the second section, I am very happy, because is talking about gates, simulation of gates, outputs, because I am working on that. That is the main base, our base knowledge. That is important thing. But everyone, you start from the base, because we have a sufficient time. Another 10 years of time is there to come into the picture everything quantum. But one important thing, especially for researchers, if the world doesn't know what it is, you publish more papers. Because no reviewer knows what we write, it is true or not. Because I take an example, when Corona started, immediately after 2 months, there are 2 Singapore scientists that published a paper when Corona ends. I discussed it with so many international professors who are working in the statistics. They said that it is not right time to predict because we doesn't know what is input, why it is spreading. But based on that, only one paper, 2 million papers are published within 1 month. Finally, they said that that paper is a basic Indian predictions. We have 140 crores people. Suddenly, 40 crore people having a resistance. 100 crores effect on the resistance. The same normal distribution or one of the distribution, the statistical knows. Based on that distribution, simply publish a paper without any base, without any deep learning. Okay. Later they got so many comments on the first paper, but no scientists decided that the paper is fake because 2 million papers are published based on that paper. So if somebody starts publishing quantum, there are so many areas are there. Quantum algorithms, quantum simulators, and quantum gates, and we write even though if you use the QS kit, that is the software is available. There is a Python library is also there. You can work. We can take a use case. First thing, identifying a use case is the major task. Research. Once identify proper, you compare with the classical with quantum. That is it. Okay, thank you very much. If you have any doubts, anytime I will be available.
Thank you very much, sir, for a very thoughtful, thought-provoking and informative lecture and for engaging us by the next speaker has come and for sharing the opportunities in different verticals of quantum technology. That is also very interesting. And the way you have thrown light on the real-time case studies, take up it as a research problem, can proceed further definitely. Thank you, sir. As usual, the way you take the students, elevate them to the next level, the same style of teaching today we have witnessed again. Thanking you once again. I invite Sahil sir to let's take our Professor Suresh Varma. Please, sir. Please. Run. Not college nature. Run. Let's sir. Please. Sir, okay, just for photograph. Run. Side. Dr. Satya Prakash, thank you, sir, for taking all the pain in coming from Chennai. Thank you for reaching us on time. It's half an hour late, but still it is okay. Now I invite Mr. Vijay from Sasi Engineering College, Tadapalligudem, to introduce the speaker.
With a profound expertise in quantum computing, artificial intelligence, and wireless sensor networks, he is a chief operating officer with prior teaching roles at the School of Computing, Shastram, DVTB University, Gargantias University, Mahabharati Engineering College, and other institutes over the past 10+ years. Dr. Satyaprakash holds a PhD in Information and Communication Engineering from Anna University, Chennai, and is actively pursuing a joint certification program in AI and quantum computing from QPI AI and IICSC Bangalore. His research focuses on quantum machine learning, optimization, algorithms, and quality of service enhancement in wireless networks. He has published extensively in peer-reviewed journals and conferences, including IEEE, IAT, and ACET contributions. In addition to his academic accomplishments, he holds multiple patents in automation and wireless sensor networks. A passionate educator, Dr. Satyaprakash Garu has mentored numerous students with some secure prestigious positions at global firms such as PayPal. He has also actively participated in international workshops and conferences, serving as a resource person and associate editor, and also a senior member of IEEE, a lifetime member of the Indian Society for Technical Education, and also a committed contributor to various academic journals and committees. Dr. P. Satyaprakash Sir has made significant contributions as a research person in various workshops, faculty development programs, and conferences, especially in quantum computing and AI. He has served as a research person for computing technologies and neuromorphic computing at esteemed institutions like the University, PDT College of Engineering, and Kumaraswamy College of Engineering. Additionally, he has been a key speaker at a prominent workshop such as the Quantum Computing Revolution at BMS Engineering College and Harnessing Quantum Computing Prospects for Development in Ghana. Dr. Satyaprakash Sir's expertise has also been sought at international platforms where he has delivered sessions on quantum machine learning and quantum mathematics, including his role as a research person for workshops organized by the Quantum Mission, IBM Education, VIT Bellu, and TQCEPT. His contributions have fostered knowledge exchange and promoted cutting-edge research among academics and industrialists. Thank you for giving this opportunity. Thank you, sir. And with this, I hand over the session to our esteemed research person, Dr. Satyaprakash Garu, and I request you all welcome with a blow of hands.
Very much interested in delivering this specific topic to you people.
Yeah. No, I'm not going to.
Earlier, I was working with Shastra University, Tanjavur. You people heard of Shastra University, Tanjavur? No, I want to tell you, we are that much happy. 90% of students of Shastra is from Andhra. 90% of the students are from Andhra Pradesh. And in Shastra, I used to teach. Right now, I am not associated with Shastra. I used to teach artificial intelligence and the machine learning. So I used to prepare 2 to 3 hours to solve a problem, especially PCA, SVM, linear and non-linear. So I solve and I go to the lecture and I will start deliver. I put on the problem statement. I start few steps. They used to complete. They are ready with the answer. That is their level of knowledge in mathematics. That is the beauty of students from Andhra. No, I am not discriminating my state student, but that is their strength. So I used to teach them AI and machine learning. So there I started putting interest into mathematics of machine learning as well as quantum computing is almost the same. Right? I think you people are very much interested in quantum, right? So you are able to crack or decode anything from quantum till now. I think you have referred materials, books, journal papers, right? So what you are familiarly seeing in that? Suppose if you take any research article from quantum, if you go through few starting from abstract, after literature study you have started seeing equations, right? Reducing equations, right? So in that equation there is several symbols also will be there, right? So this right angular bracket, rarely you can see. I think I can. Yeah. Right. See, the most of the notations are kept. Rarely you can see bra notation. So there are two notations used in quantum computing. The majority is kept. Rarely we can see bra notation. Right. That is the thing. Those equations, yes. Right. Apart from that, okay, there is a symbol. Then what you can be able to see apart from that symbols, and there is binary numbers you are able to see 0 and 1 inside your kept notation. Right, that is also you can see. That is your quantum states. That is the quantum state. Suppose we want to work with quantum computation or quantum computer science. Suppose we want to work with quantum computation, it must be a quantum state. If it is a quantum state, then only what is possible? Executing quantum computation is possible. I am not going to use full say there is a formula. Okay, right. So this is the general outline of mathematics of quantum computing. Linear algebra and trigonometry, probability measurement, one-time integral, one Fourier transform, and etc. Fourier transform, etc. And what about the definition of quantum computing? There are several definitions available. If you ask me how to define a quantum in a line, it is a linear algebra calculator. In short, what is quantum computer? Quantum computer will be a linear algebra calculator. So there is nothing inside the computer. There is no other peripherals. There is no other operations. Simply it will compute and we can able to measure output from the quantum computer. Quantum computer is also not a full-fledged computer. It is always dependent. Quantum computer is always dependent on classical counterpart. So if you look at the diagram or schematic representation of a quantum computer, there you can see waves. I think I don't want here. So the first, second and third part will be, you can see waves. Only the final part you can see meter will be there. The last part is going to be digital. So the remaining all the parts are going to be analog. Quantum computer is an analog computer. Quantum is purely analog. So that is the reason all is looking like wave. If you take a look at any circuits or schematic diagram, it is looking like wave. Only the last part is what? Digital. There is a meter. Why? Why the earlier are going to be waves and only the last part is going to be a distant. See, I am asking you to guess. I am not going to test your knowledge. I am not going to test. I am making you to guess or correlate your conceptualization and what the reality. I am not testing you. I am also like you, but I have what? We are consistently learning in that field. We are not expert expertise. Somebody calling they are expert in quantum industry, they might have at least 10 years of experience learning as well as research. So they can say they are experts. I am also not an expert. We are in that field for past 4-5 years. From 2020, end of 2020, we have started exploring quantum computer. Right? Why the last part that we will disclose. So now look at here, linear algebra. Right? Now we can split the linear algebra into these categories: vectors, linear combination, superposition, matrix, and what else? Complex. There is a new complex numbers. So far we are dealing with real numbers only, but there is complex numbers. Then eigenvector, eigenvalues, linear operator, tensor. I have excluded few operators. In later work we are having those operators: normal operator, unitary operator, Hermitian operators. Those are the major operators of quantum. To show you the clues, I have used only these: vectors, linear combination, superposition, etc. Right. Vector representation. Vector. So vector is having two quantities: scalar and amplitude and what? Right. So then what is the relationship between the vector and the matrix? That is the trick. That is what we are so much interested in machine learning. Today most of the applications we are expecting machine learning to be accompanied, right? Why? We are interested in machine learning. That is the vector and the matrix. The relationship between vector and the matrix.
SVM, because of SVM.
Vectors are collected.
Machine learning is related to SVM and they will use the algorithm.
Okay.
SVM algorithm.
No, the clue is there. No, don't go into detail. The clue is the matrix. We are revolving around matrix. Quantum computer, machine learning, and the vector is the three components. The common is what? Matrix. What is the relationship between these three and our matrix? Like in mathematics 3 we are having, in maths 1 we are having, right? In maths 1 only we are having matrix.
Intelligent equation is expressed into math.
Super, intelligent equation. Right? We are picking some numbers, yes or no? We are putting some numbers inside the matrix, right? What is that number? No, it is series of like, right?
Functions of equation. System of equation.
Super. System of equation, yes, I am happy. But what is that exactly?
Coefficients.
Column vector, row vector.
Coefficients.
It is what?
They are
The
the
scalar quantity of vector is what? That numbers. That is the number we are picking from vector, putting into matrix, and we are working it out. So that is the relationship between matrix, machine learning, quantum computer. So which is going to be exponential? The values which are going to be exponential. For those problems only we can expect quantum computation. Not for every problem quantum computers will shoot. No. It is for exponential. The values and those algorithms output will be in the range of exponential. So that is what AI, most of the modern AI optimization, right? They are looking quantum computer. Right? Vector is having what and what? Amplitude and direction. In order to find any resultant of vector, we need to focus on the scalar quantity. If you work it out, the final will be what? Resultant of a vector. We can end up with a vector. We can work with scalar, but we will end up with a vector. So that is the thing behind that vector representation. Look at here. This is also you might have seen in the quantum things. This is Ket notation. So 3 and 2. 3 is what value? 3 is the value belongs to x and 2 is the value belongs to y-axis. That is what? Here, Ket of A state comprise value x and y. So the same likewise, we are having one more state vector Ket vector B having values 1 comma minus. So this is the very first step before getting into quantum. This is the very first step. Vector representation. Right. Next. So what are the properties we can do with vectors? We can do addition with vectors. We can do addition with vectors. For example, Ket state Ket A plus B will result in a resultant vector Ket C. Likewise, if you add a quantity 3 plus 2 and 1 minus 2 will result in 4, 0. Again we will end up with the vector. Again we will end up with the vector. Pointer will be useful if I am using the slideshow. No, there is a problem with the slideshow. I cannot put in slideshow, so that's what. Is it visible? Is it visible? Okay, that is very important. You are able to see what is there. Right. Vector addition. This one. This white keyboard. This vector. I just need to come out of it. Okay, I got it. Thank you very much. Yes. So vector addition, now scalar multiplication. Again what? The product of scalar is what again? A vector. We can end up with a vector. So B is a vector having values 1 minus 2. That 1 and minus 2 is scalar. The 1 and minus 2 is scalar. So like this, what is the dot? So it is when for multiplication. 2 dot B is what? 2 dot. Already we are having a value 1 minus 2. Finally it is what? 2 minus 4. So this is your scalar multiplication. Combination. Straight away we are adding the vector quantity. So if you add 2 vectors, at the end we will get another vector. So technically it is called linear combination. Technically it is called your linear combination. So there is the vector A. If you add together, finally you will get AC. Likewise, we are having B and D. If you add together, you will get BD. So a little bit further, we are having only 1, 2, and 3. So multiple linear combinations. A, C, B, D, and E. So if we add all, we will have a final E. Right. So as per that slide, now we are having superposition. Right. So what do you mean by superposition?
But it will have different shades in simultaneously.
Simultaneously, okay, super. So this is the phenomenon gives the extra work for quantum computer. So this is the phenomenon which gives the extra possible for quantum computer compared to the classical? Yes, this one, super question. Right. So the first one is state 1. Usually it will be represented by 0, 1. The next one is state 0. The first value will be 1 and the second value will be 0. So superposition defines that at a time it is possible to be in 0, state 0 plus state 1. If we equate into, then it will be called quantum state. This is called quantum state psi. Psi is the combination of your state 0 and your state 1. This is called your principle of superposition. So what is this? 0 to 1 is called quantum states. That is the definition for your quantum computer. So what is classical computer definition? What is a classical computer definition?
Creation is the zeros and ones.
Mathematically. Anybody from computer science? Computer science. Okay, so what is the mathematical definition of classical computer? So again the same. That quantity is going to be same. 0, 1. That is the clue. With respect of 0 and 1, define a classical computer. So it will be an open challenge to you. Define a classical computer mathematically with the components 0, 1, and you can put anything as you wish. But it should define your classical computer.
Initial state, having transitions, without transition state.
It is not nearer to the definition.
It is defined by the identity.
So listen, again come back to the flow. 0, 1. In between you can do anything, you can put it anything. Transitions. No, there is one exact terminology. My voice is better than that. Yes. No, please. I think I can manage myself. Yes. 0. There is one thing. 0, capital OR 1. What is classical computer?
A number system.
0, capital OR. What is capital OR? At that time it is possible to have only one state. That state might be 0 or 1. So it is not possible to 0, capital A and D 1. That is the definition of quantum computer. Classical computer definition is what? 0, capital OR 1. So what is that? It means at a time possible to have only one state. So what is that state?
Either 0 or 1.
Super. Wherever I go and I ask them what is 0 and 1, immediately people will say binary. Bi means 2, tri means 3, and tetra means 4. But what is that 0 and what is that 1?
0 is low state.
I don't know. Super. Somehow you are came into close. But exactly what is that 0 and what is that 1?
States.
Now we will go to the classical definition of computer is what? Computer is an electronic device. Semiconductor operated by electrons. If your electron hits any of your hemisphere, suppose if it hits the upper part, maybe it will be 0. Suppose if it hits the lower, maybe 1. So 0 stands for your electron spin. It is semiconductor. It is what? Classical computer works on the principle of classical computer 0 or 1. That electron spin cannot be captured for multiple states is not possible. So still we are playing with only real numbers. There is no need of extra quantity. Complex number is not at all required. Why? We are having only limited amount of numbers Extra projection is not at all required. Right. So what is superposition? So superposition states that at a time quantum system, not a computer, it is possible to exhibit by nature. Nature gives what is it? Quantum phenomenon. Both states at a time is possible. The both states will be your 0, capital A and D, and your 1. So this is the definition of your quantum computer mathematically. If you know mathematically, then only we can walk a little bit further. First 2 years, we are walking around the paper. We are always reading the book, and we are always circling around. We never able to get into the topic because we are not. We means that we are a team of 3 to 4 members are there. We are exploring quantum. So then what? Where we went? So if we know the mathematics, then only possible to understand the quantum computation properly. Right? So this is your superposition. Right. So what is the sum of scalar? What do you mean by sum of 5 1 and 2 minus 1?
7 0.
7
0.
Okay, super. You can try. Note down this and you can try. Then solve the following: 3 minus 2 1 plus 5 3 minus 3. So you can try. Note it down. You can try. See, once you start do this, you will be getting closer to your quantum computing basics. Right? X dot dot 2. This we will see in the upcoming. Right. Now, matrix. So how to define a matrix? Already there is an answer. Rows and super rows and columns. Simple matrix operations. Matrix multiplication. Then quantum gates. Then quantum gates. Look at this. So if we want to multiply two matrices, how much power we need? How many elements will be there? 2 cross 2. Output will be what? 2 cross 2 only. But what is the steps required? We need to work it out these terms with that 4 into almost 8. We need to deal 8 components. 2 cross 2, small d. 3 cross 3, still small. 4 cross 4, small. 4 cross 4 cross 4 will be small or big? Definitely it is going to be. So that is why semiconductor based device cannot be able to handle. We are looking for, as of now, IBM explores quantum computing through superconducting. Exploring through superconducting. So their subatomic particle behaviors comes into picture during what time? If there is Kelvin, if the temperature is maintained between kelvins ranging from 1 Kelvin to 4, 5, 6, what is there? That particular particles emits computation. So that's why we need special setup, cryogenic setup. So we cannot able to see superconducting based quantum computer. We cannot able to see in any rooms. It will be protected environment. Cryogenic Cryogenic is not classical physics. Cryogenics is almost what? Quantum physics. Cryogenics is what? Quantum physics. Right? So N cross N and your rows. Right. Addition, scalar, matrix. The last one is what? Matrix vector multiplication is not simple. It is going to be complex. It is going to be. So that is why heaviest machine learning data set. So what is the order of values which you have seen in machine learning data set? Suppose you are going to do CNN, a small size CNN problem. What is the computer you need? You need 16 GB RAM with what? Some that accompanying central processing unit is required, right? So what is it? If it is going to be 100 epochs, 1000 epochs, it takes ranging from 10 minutes to so on. But there is one thing. People are thinking that simply if we apply QML, there is results. No. Simply if you apply, it won't work. So there are some additional mechanisms are required. Then only what is possible to see that quantum advantages over machine learning. We can able to see. After all, we are going to see that only. Next, complex numbers. Next is what? Complex numbers. I think yesterday you have discussed about block sphere. Yesterday I think you have seen block sphere, right? How many axes are there? 3 axes are there, right? Normal numbers we can handle x and y, but with the help of normal numbers we cannot handle the third dimension.
Imaginary axis.
So for imaginary, in order to handle imaginary, definitely we need complex number. What are the numbers available in complex? I is what? Value of I is root of I square. So that is the expression of complex number. Z equal to B plus I. Whereas the B I is what? The value which is available for your imaginary. And then A is what? Your real. Combination of your real and imaginary is going to your complex number. So then what is possible? Projecting the quantum, not calculating, projecting the computation in the special dimension or what? The block sphere is used to visualize quantum computing. That is it. Block sphere is used to visualize your quantum computing, not to compute, is to visualize, to see where your projection, how the value are what? Projected or rotated. X square is -1. Then what are the various ways? Cartesian, polar, and what else? Various forms to represent general form, or we can say Cartesian and the polar exponential. So values which is known in nature. In order to represent the problem distribution over block sphere, we depend on complex number. To visualize, we need the third entity, we need complex number. Okay, any doubts so far? I think yesterday you discussed detailing block sphere, right? Any doubts? No. So we will do. See, and I have noticed. So look at the x and the normal. Normally in graph we use x and y axis different. Look at here. Here x belongs to this side. X belongs to this side and y, and then z is the considered as what? The third entity or additional. Look at here. There is a slight difference. X is here, and y is here. Z is here. There is a third projection which we are using in quantum. Yes. Likewise. Now, yesterday you have discussed block sphere, right? What is it? 0 state and the 1.
Pure states.
Pure states. Okay, super. Good answer, pure states. So, which is going to be your pure state? 0 and 1. What is it? In classical, it is electron spin. In quantum, what is it? 0 and 1. Any guess? Trying to guess. Polar coordinates. So what we have seen in cryogenic setup, specific particles try to exhibit subatomic nature. Subatomic nature. So if it is in ground state, if the particle is in ground state, state 0. If the particle is in state 0, then what is that? That is state 0. If the particle is accelerated or it is kept in a cryogenic setup in that millikelvin temperature, then what? It goes to excited state. That excited state is what? Your state 1. So that is 0 and 1. Ground as well as excited state of your subatomic particle. Excited state of your subatomic. Then, so what is this? So 0 and 1. So then what is this? Minus state minus and state plus. So actually we rotate the quantum computer. What is that operation? Possibly we can rotate. If you rotate on that x-axis, then it will be your plus. In the opposite direction to that, if you rotate, it will be state minus. Product of Hadamard gate. If we apply Hadamard, it will result in what? Either it will be resulted in plus or it will be resulted in minus. That mathematical we will see in the next lecture, which we are having in quantum computing in its basics. 0, 1, plus and minus, I and minus I. Various states, linear 90, linear 0, linear 45, Hadamard, minus what we Hadamard minus counterclockwise. Right, super. Right. Whenever mathematics, these variables comes into picture, we Indians are what? Substitution kings. We Indians are what? Substitution kings. If they provide some values, we substitute as much as speed as possible. But you ask what is the x and y, they will be gone. They will be gone. So we should study mathematics in what? Variable level, not in substitution level. So why we are struggling means our teammates. While decoding the quantum computer, we are also one among you substitution kings. We are not variable kings. Right? Probability. I think machine learning experts will be there in the group. Right? What is probability? What is the basics for machine learning? I have a question. I will give you a data set. What operation you will carry out? Which decides it? Data. Super. But how you will hold the data? Before training. Don't go to training and all. My question is what? How to deal it? That is my question. We are having data. We are having a data. Which parameter decides what to do? Size. No, not the size. Quality. No. See. Variable which holds that value. There are two types of variable. Continuous random variable, discrete random variable. Your random variable only decides what is to be done. Either it should be classified or it should be predicted. Not there is a data set we cannot classify. Directive data set we cannot predict. Which random variable is there? If it is C or V, what is possible? Majorly we can predict. Minorly we can classify. If the random variable is going to be continuous C or V, double integral area under curve is there, what is possible? Prediction is possible, I think so. Prediction is possible, I think so. What is contradictory for C or V? Integral, no, if it is not, what is the contradictory part of integral is what? Discrete random variable, continuous, contrary is what? Discrete random variable. If the data is holded by discrete random variable, what is possible? Majority classification is possible. Rarely based on the outcome we can predict something. We can predict some. So which decides your learning process? Your variable only decides your learning process. Whether it is continuous random variable or discrete random variable. So what are the properties of DRV and CRV? PMF and PDF. Probability mass function, probability density function. So which associated with what? PMF associated with which one? And the PDF is associated with which one? Yeah. Now we have to conclude the random variables available in quantum computer are discrete random variable. What is that? The value. Most of the values of your quantum computer is what? Discrete random variable. So possibly what we can hold, head or tail, flipping a coin for a 0 or 1, right? So that is what the probability. Then, and what is the next terminology you are seeing it out there? Measurement. In the entire schematic diagram, most of the what? Initial, intermediate, and the last but one steps are going to be analog. And the last part is digital measurement. What we are doing there. Once we measure, what will happen? Collapsed. Superposition got collapsed. It will be revealed. It will be revealed your pure state 0 and 1. And there is one more. What is that? How many times are 0? How many times are 0? And how many times are 1? That is what measured. For that we need probability. If 100 times are there, out of 100 times, how many times belongs to your probability? For state 0. The probability of having state 1. That is the combination of your probability and it should be measured. So what is the property? It is a discrete random variable property. Then it is what? Probability mass function. What are the properties of mass function? It is a standard deviation, expectation, variance. So what is the output of your expectation? What is the output of your variance? So that is what we are doing in quantum computing. There is computation. In order to carry out those computation, we need probability and it is to be measured. So this is what happening internally. This is what happening internally. Example for discrete random variable. Flipping a coin or rolling a die. These values we can hold by using discrete random variable. In quantum computing, experiment is what? Measuring your qubit. Experimentation is what? Measuring your qubit. Most of the random variables are discrete. Most discrete. Then principles of quantum mechanics. Wave function. What is it? How it is possible? Whenever you see any workshop or seminars from any reputed institutes, IAC, IIT Madras, right? If you gone through those brochures, I think you might have seen something. Some physics experimentation you have seen. What is it? Double slit experiment. You see, if you gone through the IAC quantum computer brochure, there is what? Double slit. So what is the purpose of double slit? What is the purpose? We are verifying that in nature it is possible to have two states. We are keeping a light source. From the light source, light is emitted. There is a slit to split it into two particles. Particle 0 and particle 1. At the opposite end, there is collector or detector. Detector for 0 and detector for 1. So there we are what? We are provided one single light source. We splitted. At the end we are having what? So it is proven in nature that we are having what particle? Quantum mechanic behavior is there. So that is what your quantum mechanics. Quantum mechanics denoted by what? Wave function and symbol is what? Psi. So that is what in earlier Superposition we have seen what? Psi is the quantity of alpha times 0 plus beta times 1. Okay. If it is then what is the property? If it is having this nature, what is the property? Alpha times 0 and beta times 1. What property we can conclude? It equals to 1. Psi is what? Alpha times 0 plus is equal to 1. What is it? So what is it technically? It says magnitudes. If you work on the magnitudes, it is always 1. Suppose 1000 times we have did experiment. Suppose 300 times state 0. What is remaining? 300 plus 0 is equal to 1. 300, 1 minus 300 is what? 300 minus 1. If you remove that portion, you will come to know what the beta value. What is the beta value? 700. If we add, then we will end up with what? So that is what we are concluding. With the help of nature and mathematics, we are concluding that what? Psi is what? Alpha times of state 0 plus beta times 1, and their amplitude is what? 1. So that is what your principles of quantum mechanics. Principles of quantum mechanics. Then, and there is something called the constant. There is something called constant. So in that, which part is constant? Look at the expression. Which part is constant? Idra super jolly. It is funny. So far it is funny. Once we will enter into operators, little bit it is going to be having the flavor of linear algebra, and then you will be able to see some operators, some symbols. It is there in the note. In one note I have all those worked out things. Right? What is that? Which is going to be constant? Look at this equation. Which is constant? This is going to be constant. So what is that? C. How to decide that constant? How to decide that constant? So now for this we need the help of machine learning, PCA. We need help of what? PCA. What is PCA? Super principal compound analysis. How to work it out? How to work it out? So there is one characteristic. While proceeding toward the eigen value and the concluding eigenvector, what is the first step? There is a characteristic equation there. So what is the characteristic equation? Lambda I. Lambda times I. Then what is that lambda? That is your C. That is your C constant. So in order to conclude your quantum mechanics behavior, we need eigenvalue and eigenvector. So if you work out this, it will go very big. So how to make out the essence? It is what? Pick out the one portion and what? Mapping into the remaining with the help of the principal compound. Likewise, with the help of eigenvalue, we are handling the remaining unprojected parts. Unprojected. This is what electron being done. Our double slit. Look at here. Ground state. So based on this only, quantum information bit, in short, qubit is constructed. Generally this is qubit. There are types of qubit are there. So based on the type of qubit, quantum computer types are varied. IBM is having got superconducting, trapped ion, photonic quantum computer, nuclear magnetic NMR quantum computer. The qubits are what? The basic parts are going to be the qubit. Then the type of the quantum computing is what? Decided. So this is ground state and there is subatomic particle behavior. Two-state quantum system, hydrogen atom, n is equal to 0 and n is 1. So 0 denoted by your ground state and 1 is your excited. Spin of likewise, spin of electron 0.5 1 by 2. The other is going to be 0.5 1 by 2. So here it is what? Polarization of light. So in an overall view, what is happening? Light wave is what? Wave function happens. Finally, to determine that, what is it? There is one more process. Polarized light is passed through that. Then that deviation is what? The computation. That is the output. That is our measurement. That is our measurement. Visual representation of qubit. It's a quantum state of form. State psi is alpha times or 0, beta times of 1, where alpha and beta are complex number with alpha square and beta square is equal to 1. So this is the principle of quantum information. This is the basic or foundation step of quantum information. So that is the value available inside our qubit. What is that? This is the value available inside our qubit. With the help of eigenvalues and eigenvectors, we are transforming the matrix. This is the representation. So measurement done with the help of eigenvectors. Right. Now we are only actually entered into quantum computing. Operators, various operators available in quantum computer. So starting from normal operator. Normal, Hermitian operator, unitary operator, projection operator, positive operator, then tensor operator. Whenever you hear about tensor, you are happy, right? Already you know tensor, right? But this is normal operator. A cap dagger is equal to A cap dagger, and A cap is what? Normal operator. Hermitian, unitary, and the projection positive operators are normal operators. Let's note it down. It will be helpful for you. Next, Hermitian. Note down the expression. Later we will see the theory. A cap is equal to A cap. See, what is this? I think you might ask, what is the dagger symbol? Super. Complement, conjugate. Complement is what? The dagger symbol. Dagger symbol. Next, unitary operator. Unitary. U cap inverse is equal to U cap conjugate complicate. Then lambda Modulus lambda is equal to 1. So what is lambda? Whenever lambda comes into linear algebra, what is it? Eigenvalue. Eigenvalue is what? Eigenvalue is a real number. So what is the first property? Eigenvalue is a real number. Then what is it? Eigenvalue is having the protection. Yes. Then inner product. Just simply note it down. It's for your understanding. We will see the theory. I think this is the expressions you will see in any reputed textbooks for quantum, right? This is explained in the initial part of what your quantum textbooks is what quantum operators. What is this x and y? This is what rotation? This is Varma rotation conjugate. This is what normal head rotation. If you take inner product of two vectors, then what is output?
Scalar code.
Scalar. This x and y is what? This x and y is next positive operator. The next one is expression. For expression, I have used what? One note. So what is sign? Sign is the principle of superposition or superposition. And what is this? Look at here. It is greater. This is positive definite. If it is going to be greater than 0, it is positive definite operator. If the value is greater than equal to 0, positive semi-definite.
I think not of the operator.
This one. This is
But
the values between the two states. Right. This is positive definite. Normal positive, positive semi-definite. That is why there is one. Positive, positive definite, positive semi-definite PSD. Positive semi-definite. Okay. The last one is what? Apart from this, the next one is going to be tensor. Tensor is what? Almost the normal operator. So theory begin normal. Commute with the adjoint of with adjoint for an operator. Normal operator diagonalize hermetic, unitary, positive, positive semi-definite are all normal operators. The eigenvalues are conjugates of the eigenvalues of adjoint. So that is the expression we have written in that. Normal operator 31. Next, Hermitian. Eigenvalues are real. Then what? All the measurements of quantum states are done through Hermitian. If you want to measure, we need principle of quantum mechanics is what? Handled through eigenvalues and eigen. Unitary operator. Unitary. I think we can have a break. Let us stop here. We will continue with tensor. So tensor will be interesting. After tensor we will stop. So you will be able to understand the quantum computing definition. Then we will move further how it works. Parts of quantum computer in the upcoming lecture. Let us stop here. We will continue with tensor. Tensor will be interesting. I think this also will be interesting. First time maybe you are unfamiliar, but once you start practice, you will become familiar. But if you are familiar with this, quantum computing will be possible to handle, or else it will be what?